Hi, in this video, we want to take a look at using simple format map data in ggplot. All right, so what I want to look at in particular here are functions that we use to get to our goal. So we're not talking about functions that we use to execute our goal, because in this case, it's to make a map. These functions are ones that are like intermediate steps between receiving our data and actually executing what it is we want to deliver. All right, so what you'll find frequently is that what we have for data out of the box is not actually what we want. And this is no different when we talk about maps. Okay, so what we're going to do, we're going to need to do a little bit of data prep, a little bit of massaging, get ready, get it pretty, get into the right format to make our presentation and our results absolutely snap. All right, so this example is modified from Hadley Wickham's book, ggplot 2 Elegant Graphics for Data Analysis. Here is the GitHub page if you want to look at the original code. I've modified this quite a bit because much of the code didn't work for me from copying and pasting. So I modified things and also changed things for my preference on coding. Now, if you go through and read this, you'll notice that Hadley, says like I, do this, I did that. He is referring to himself, and also references that he makes are to his own book. And if you go to Amazon, you can buy it. If you go to Springer Link, you can get it. The book is free through a lot of university library systems for download. So it's a good book. All right, so what we want to do now is we want to take a look at some tools I have to get what I have for data into a format that I can actually build a map within ggplot. All right, so some things that I, just playing around, working through this, seeing how things work, I found like 3 particular tools for taking data that I have in my hands and converting things over to the actual format that ggplot will accept. All right, the first one is to go ahead and use like the str package to see what is it that we have in our data sets, look to see what its label is, and just pull exactly the geometry we want. And so I achieved this using the $ geometry terms. Now, for the data that I had in this example here in the video, what I wanted was labeled geometry. It's possible that it could be labeled as something else on your data set. So use the str package, the str function to look at what you've got going on. If it looks like it's the actual points for a shapefile, it's probably what you want to grab. Now, the next one, this pull function, if I want to grab particular data from a data frame, the dplyr package has a pull function that does this very nicely for us. In the examples from the book, Hadley used pull, and that code did not work for me, so I'm not going to talk about it any further, but it was in there, so I'm pretty sure it could be useful down the road. Now, the one that is the heavy hitter, the one that solved some problems that were giving me a headache for this video, was to go to stcast and from the SF function. What this does, this takes it and puts it into a format of your choosing. All right, so let's go ahead and take a look at stcast from the SF package. All right, so we've got this data set here for a map. Now, if I go through and I plot this, I have no problems at all, honestly. I was able to drop this into ggplot on an active session. But when I crossed over to R Markdown, which this document that you're looking at right now, it was built in R Markdown, for some reason I was getting errors and I was puzzled, didn't know what's going on. Well, the trick to bust it, to get it to work, was to use the cast function to convert it to polygons, and then boom, easy peasy lemon squeezy. Okay, and so for us, we really don't care what the data set really is. We just care about how do we get it into ggplot to build the map that we want. Now, something you'll notice, there is a warning output that is saying that the old CRS object detected. All right, so the coordinate system is not like up to date. So what this is just saying, hey, go ahead and use a more modern coordinate system when you go through to actually plot your map. And in my example, I did that. All right, so I use ggplot here. And so now realize that this is the cast version of this. This is the polygon version, not the original data set. The geometry is the geometry. I actually didn't need to specify this. ggplot would have figured this out, but I like to be explicit in case there was a different name on the data set that you're using. And now here, because of that warning message that I received, I went ahead and went with the coordinate system that is common for GPS. All right, and now we can go ahead and take a look at the US boundaries from 1820, and we can see like, hey, the Americans lost out on some of Canada from 1820. Huh. Maybe we should go get it. Maybe we should take it from them. I don't know. We could have, even more area. I'm sure they're not keen on that idea. All right, so now let's go ahead and start digging into another data set where we're going to use a wider range of tools to interact with. Okay, so I'm going to be doing some piping, and so in the piping I'm going to need the Magritter package, and so, because this is the package that has piping. Magritter was a famous professor that always smoked a pipe, and because of that smoking a pipe, he got his name attached onto this. All right, so I go ahead and from OzMaps, I go ahead and grab the map data set from the Australian Bureau of Statistics, and we are interested in Eden Monero. Now, if I was to execute the raw code that was posted on GitHub, on my machine, it didn't run. All right, so I had to figure something out. Well, what I did was I pulled only the geometry. So here, this is only going to be geometry from the original data set. All the other stuff is lost. So that's something I need to be mindful of if I'm going to start doing more interesting things. I lost much of my metadata when I did this. Okay, now to get down to the actual geographic region that I want, I went ahead and I filtered out with a logical statement where I set name equal to Eden Monero. All right, and so when I'm done with that, I can see I have a multi-polygon. It's on the XY coordinate. The coordinate system is GDA 94, and we can see the bounding box. Now, when I do this filtering, it automatically figures out what is the bounding box that's best for this. It looks at the minimum latitude and maximum latitude, minimum longitude, and maximum longitude. All right, so let's go ahead and just do a quick plot. I'm just going to slap it down. All right, so using ggplot, and I'm saying, hey, this using geom SF, I'm saying, hey, this is a map. Make sure you treat it as a map. Keep the ratios at 1, the aspect ratio. That way I don't have any stretching or distortion to fit the plotting area. Okay. Well, something that I can do, let's say that I want to change the focus. And I don't change the focus much, but I think, you know what, this is a little bit much for a little bit of margin. Maybe I want to like get a little bit more focus or on a particular region. Well, what I can do is I can use coord SF. I can specify the X limits and the Y limits. Now remember, X limits go with longitude, Y limits go with latitude. So X and Y and longitude, latitude coordinate names are reverse of alphabetical order compared to X and Y. That's how I remember it. All right, and there's not much of a difference. I mean, there's a little bit more zooming in, but it's not that big of a deal. All right, now let's say I was interested in a very specific region. Let's say I'm interested in the northeast region of the area. Well, what I could do, I could even further trim down that box. So now my longitude is narrower, and here's my latitude. So like here, so it's not the northeast region, I misspoke. Here's that little tiny island. And on this scale, that island, you could easily miss it. You could think it was like a coffee stain on your screen or something like that. Well, here, when I zoom in, that island is very obvious. So, this is why we like to be able to control our zooming in. So this region has two distinct polygons, one for a mainland and one for a small island. Now, something about this is that this region also has a hole in it because there is a capital territory that is completely surrounded by this particular territory in Australia. All right, so now let's take a look at some helper functions. So ST geometry type from the SF package extracts the geometry type, such as polygon, multi-polygon. SF ST dimension extracts the number of dimensions. So it's more than likely going to be 2 or 3. The SF package STB box extracts the bounding box as a numeric vector. And then SF ST CRS extracts the CRS as a list with 2 components. So here, we can use this if I want to change some things up, by the way. All right, so let's go ahead and get that bounding box. And so here we can see the range of the longitudes and the range of the latitudes. We can get the geometry type, which we see is multi-polygon. And we have 18 levels for that multi-polygon. We can get the number of dimensions, which is 2, X and Y, not shocking. And now we can extract the coordinate system that we're using. All right, so we got 4283, that's not a surprise. I can get the geocentric datum of Australia is my datum. I can get the ellipsoid information. We can figure out that everything is the latitude, longitude is in reference to Greenwich, not really surprising. And other information if I want to start digging into it. Now, if I print just the object name itself or how I stored it, then I get, much of this information gets spit out for us. Now, the CRS is much shorter, but it's giving us, the most important aspect of that. Now, the cast, this is how I convert to another format. And I found that casting to a polygon is a good choice when I need to start working with something in a different format. All right, so when I do that, you can see that it changed the geometry type. But the rest stayed the same. All right, now why would we want to do this? Well, let's say that I want to start working with particular aspects of it. Well, let's take a look at this map. Let's say that I look at this map, and for the project I'm working on, I'm not interested in the big part, I'm interested in these smaller islands. All right, so here for this example, we're going to look at the Dawson region of Australia. And how I tackle this is I take the AusMap, Australian Bureau of Statistics data, then I grab only the geometry from the data sets, but I filter it so it's only the part that's connected to Dawson. All right. And so now I can just drop this in very nicely to get it to print up. Now, let's say for my project, this is a very good map, but for my project, I'm not interested in, this larger region. I'm only interested in these smaller islands. All right, well, what we could do, we could just not plot that big chunk of geography. All right, I just want the small islands. So what I'm going to do is I'm going to use the ST area function from the SF package. I'm going to find the area of each of these regions, of each of these little tiny islands, and then I'm going to find whichever one's the biggest. And what I'm going to do is I'm going to exclude the biggest from my plot. Therefore, I will only get the smaller islands. All right, so first thing I got to do, I have to have the same format that I can work with. So I use stcast to convert this over to polygons. Why am I doing this? Because I want the area of each individual polygon. Each island is its own polygon or connects to its own polygon. Then I compute the area of each of those polygons. I find which one is the largest. I know that the largest one is the one I want to exclude for my project. And so then what I'm going to do in ggplot, I'm going to run everything like usual, but you notice that I'm filtering out the part that has the largest area. And so now on my total plot, very nicely, I can see that I have just the islands in the Dawson region. All right, well, that's all I've got for you. Take care and goodbye.